I'm Max Clark, and in 25 years of my career, I've had the pleasure of being able to work with some pretty amazing people. And lots of them have changed the way I've thought about things and looked at the world and how technology impacts it. And what I want to talk about right now is optimization and knowing when and why you're optimizing. My best example of this that happened was the beginning of 2009. And we had a customer in our data center, and they had ordered a new server and then a RAM upgrade. And so my team was doing this RAM upgrade for them, and it was a very large box. Quad socket, multi-core, Dell server, and we were adding, I think it was 128 gig of RAM. I have pictures of this somewhere. I'll find the pictures and try to include it with this. In 2009, adding 128 gig of RAM to a machine was just an astronomical amount of RAM. Plus, like a quad socket Intel machine was pretty unusual. So this was a very big box. And I was talking with a software architect and just was asking, what are you guys doing with this thing? And he told me that they were using it to run parallelized sed and awk scripts. And boy, this really made me curious. What do you mean you're doing a parallelized sed and awk scripts? This is kind of okay. This is interesting. And it was an ad tech company, and they were taking and they had pods of ad servers, and these ad servers had to make a decision of what response to send back to the client. A piece of JavaScript of what to display, what to just put in the browser. And this parallelized sed and awk process job would take the logs off these servers and parse them and summarize them and insert the summarization into a Postgres database. And it was doing this at an interval, so that way they could get updated counts and know where their job performance was at, and have they hit the ad targets that they needed with their customers. Have they not? Did they need to serve more ads? Which ads should they serve, etc. So this was the pipeline that maintained all those backends. Now, in 2009, we've got lots of other things in the market. MapReduce had been out, so Hadoop had been out for a long time. Extensions to Hadoop and these systems like Hive had been around for a while. And there were a lot more elegant ways of doing this job than a parallelized sed and awk process. I mean, heck, even writing what today you would probably put into a Kafka process. Kafka didn't exist back then, but implementing a first in, first out queue system, queue, a message bus with some kind of workers to take and process that data was readily available, and there was plenty of options in the market in order to actually accomplish this. Anyway, so I was fascinated and I was curious, and I was so confused as to why this would be the direction that they were taking. And what he told me was that by spending, I forget the dollar amount, but he had they just spent the money, they knew it, and spending a couple $100,000 on this machine and upgrading the RAM in order to run this process would save him 6 to 9 months worth of development. Now, this wasn't saving him 6 or 9 months worth of development on other teams. It was just delaying the time at which they needed to do the development by 6 or 9 months. So he knew he could spend a couple $100,000 today and kick the can down the road and continue to focus on building product to deliver to their customers to generate revenue for the business to grow. And it was a wonderful conversation. I'm so grateful, that we had this talk. I mean, there's a lot more detail here. I mean, this isn't like a 5-minute explanation of a hour plus long conversation in terms of how he was thinking about scaling his software teams, scaling product delivery, what they were doing for hardware selection, how they were picking platforms, why they were doing one thing versus another. I mean, we really went around, we really went around the horn with this one. It was one of those moments, though, for me that really brought trade-offs really to front of mind now and ever since then in terms of technology selection and implementation. Today, the modern version of that comes in the form of cloud services. So this could be either an expression of an as-a-service type of solution. It could be a public cloud service. It could be a platform as a service. So there's, of course, infrastructure options where you can publish directly via a Git check-in to actually deploy code without doing any things. You can get into a Kubernetes-style environment where you're creating, containers. You could still be managing infrastructure on top of a cloud, and you can go down the stack and you can get closer and closer. And what triggered this recording for me was a conversation I had recently with a CTO, and his frustration and the quote was that he wanted to get closer to the metal. Now, he wasn't talking about in terms of like cloud, and he wanted to go from a cloud service down to running their own servers. He was talking about frustrations of dealing with layers of intermediaries and APIs and having issues with observability and performance and cost. And so for them, as they were building and scaling their application, they were using an intermediary, which in this case, I know the company very well, and I know the makeup of what intermediaries that aggregators and resellers that company is using, and then who's the actual underlying providers for the service. And the discussion really came into whether or not it was time for them to go from here in terms of like, if this is bare metal and this is the actual metal, right? And up here, and there's all these different layers in between. And what each one of these layers represent is really additional cost and margin that solution provider is adding. What is the efficiency? What is the time to market? What is the ease of use? What is there's some value that in theory is being created. Maybe it's just you can't get access to the very bottom because you don't have the volume to commit to it. And so you need to have a reseller in play in order to get access to the system. Now, that wasn't the case here, but the example is, at each tier, as you go up through different resellers and intermediaries and aggregators or solution providers or whatever you want to call this, in theory, in addition, in exchange for charging margin, they're creating value for you. And then understanding and making a determination of where you want to sit in the stack. Right? Do you make a trade and say, okay, I know that right now it's better for us to interact at this tier, and because it's going to save us operational costs and overhead and complexity and things that we don't want to deal with right now. And that's a great trade. I mean, if you're conscious and you're making that trade, make that trade. Take it every single day. Just be conscious of the trade that you're taking and understand that there are going to be times where it's going to make sense for you to start jumping down the stack and moving farther and farther down. I see this a lot right now. If we talk about, we see a lot in telephony. So anybody that is interacting at some point with a PSTN interface, or if you're doing messaging, whether that's SMS or WhatsApp or Apple Business Messenger or these different platforms, you have an option of interacting and going through the energy of going all the way down, in this case, going all the way down to the metal, we'll call it, or finding an intermediary and working your way up and trying to find ease. And whether that's just, again, volume commitments, or maybe you're not at a position where you can sign a contract to commit to something, that's going to put you up here, and that's fine. But then when you're at a point that you can commit to something, you can jump down one or two spots. And this is a great place as you're evolving your operations and as your business evolves to really understand and kind of keep that in mind of when it makes sense to jump down. And by the way, jumping down usually also creates other advantages and strategic differentiation for your business, for your product and service. And if all your competitors are running up here and you figure out how to go down 3 levels, you can take advantage of that change. So in the compute and infrastructure world, right, I talked briefly about platform as a service. And when I say platform as a service here, what I mean is again, these systems where you can just do a git push and it orchestrates the entire infrastructure for you, right? So everything is a black box. You have no idea what's going on. And there are wonderful, easy environments to use and develop with and be quick with and not have a big team around it. And then you go from there into, what we consider public cloud, right? The hypervisor environment, the hyperscalers. I really don't like that term, but the public cloud environments, the AWS, GCP, Azures, or maybe, a Linode or DigitalOcean or, Oracle or IBM or whoever is there for whatever particular reasons you're using them. And then you get into a position where you start looking at and talking about, do you want to go serverless with those platforms? Did you go down a container environment with those platforms? The trade-offs of serverless is now you're building code that becomes very specific to that platform. Serverless is not a technique to give you portability between cloud providers. Containers are wonderful, though. Containers, in theory, can run it anywhere with relative ease. So if you're looking at this and you have legacy infrastructure, legacy code, legacy applications that are still running on compute instances, and you're trying to figure out where to go from there, it might make sense for you to go to serverless. I would tell you it probably makes a lot of sense for you to go to containers as a next step, anyways, because that unlocks a lot of flexibility for you. And then once you get into containers, now you can start making other decisions. Do you stay in that public cloud environment, or do you move your container and your containers out into something else? And I find this misconception that this moving out of public cloud means moving back into the stone ages of what we did, 10, 15, 20 years ago of having to go and build out your own data center or going into a colocation environment and buying your own servers. And that's absolutely an option to you. You can, we can help you get a colocation facility, and we can help you purchase servers from a bunch of different, OEMs and ODMs and help you manage it. And it's not hard. It requires a different muscle and operational process for you to get into. You just, if you haven't had experience with it, of course it's scary because you've never done it. But, once you do it, it's not that bad. You have to keep track of equipment aging and, hardware refresh cycles. And, you don't just buy a server once and it's going to run for 20 years. There is some level of a refresh cycle that you have to get into. And that trips a lot of people up because they don't really plan for it. But that's all the way over here. And there's lots of options. If public cloud's over here and running your own data center, buying your own servers is here, there's still a ton of options in between those 2 points. You can go to, there's options for managed data center. There's options for managed servers. There's VPSs. There's bare metal providers. There's managed Kubernetes providers. And the trick now becomes, at what, again, we're talking about this stack up and down. I'll stick vertically. Just where you want to sit within these things. And the point is with each level that you come down, in many cases, what you're doing is you're adding operational overhead to you. You don't have a lot of operational overhead with AWS. I mean, you do. It's not zero. You still have to have a team to manage it, right? But you're not driving to a data center and changing hard drives out. So we'll be clear about that. So you're trading operational overhead, but what you gain in terms of that is cost and cost differential. And I've talked about this a lot. I won't beat this one to death, but the cost of compute is really it's really the distraction prop in cloud. Everybody gets focused on compute, and we can tell you all the numbers and difference between purchasing RIs in AWS versus buying servers and co-locating them. But the cost of compute is really the distraction for the real cost suck in cloud, which is your bandwidth costs and your egress costs. I'm not going to go down that road right now. Anyways, the point of all this, again, to circle back and start at the beginning, is just understand what trade-offs you're making. And it's not bad to say, hey, we want to be here and we know why, and this is the trade-off we're making. That's actually a great place to be. Just be conscious of what you've decided and know that any decision you make shouldn't be a permanent decision. In 2 years, you could be in a completely different situation and need something else. That's okay. And just get ahead of it and use it to scale your business and scale your operations and refine your service and get better and build moats and have differentiation and create competitive advantages and everything else you need to do in order for your business to to succeed and win. So I'm Max Clark, a quick rant on trade-offs in infrastructure, and I hope this helps you somehow.